Okay, finishing up with the night sky, I'm going to talk about other objects which are there, and then we're going to end with eclipses. What else can we see in the nighttime sky? Well, comets. Comets are probably one of the most exciting events for the nighttime sky. And as we'll see later on, comets are icy bodies made of rock, dust, and ice, which when they get very close to the sun, develop this beautiful long tail. They actually develop more than one tail. They develop a plasma tail and develop a dust tail. But comets are exciting events when we get a gray comet, a very bright comet. More often than not, there's usually a comet that is up in the sky someplace, but most comets, even on their closest approach, really need a telescope to see. You really need a telescope, and when we look at them through a telescope, it just looks sort of like a fuzzy star. But when we get a really great comet, that's when, even to the naked eye, it looks impressive. Comet Hale-Bopp, many, many years ago, was one of those very impressive comets that I actually saw back when I first was working here. Started working here. I don't want to say how long ago that was, but it was a few decades ago. Right now, we don't have any bright comets. If we do have suddenly a comet appear, I'll update you and let you know where you can see it. But again, great comets, when they do arrive, it's very infrequent. Meteors, we'll talk more about meteors when we talk about comets. Meteors typically take place any time of the year. You really need dark skies to see them, but they're more frequent during what we call a meteor shower. And this happens when we pass through the debris left by a comet. They happen periodically. There's about 12 bigger meteor showers. And although it sounds more impressive than it is, you really need dark skies, and at best, even the best meteor showers, you'll maybe get a meteor per minute. So you've got to be very patient. Asteroids, technically we can see, I believe, Vesta and Ceres with the naked eye, but again, they're right at the edge of what your eye can see. Okay? At magnitude 5, you really need the darkest skies. In perfect skies, technically you could probably see down to magnitude 6, but again, magnitude 5, there's thousands of stars out there that are brighter than these asteroids. You really need to know where to look. In terms of looking at them through a telescope, they just look like a star. In fact, the term asteroid, aster, star-like, basically refers to the fact that when they were first discovered, they had a very star-like appearance. Auroras. Auroras are an interesting interaction between the solar wind from the sun, usually when it's highly magnetized and filled with a lot of charged particles, and how it interacts with the Earth's own magnetic field. Auroras are almost impossible to see from the city. Jersey City, you're not going to really see an aurora. Now, I live about 80 miles north and west of here, where it's dark enough to see auroras, and here's some pictures that I actually took. This was back in 2015. Aurora that took place. I took this right in my backyard. And using a camera, it actually looks more impressive in the photograph than it does look visually. Again, auroras in person are very interesting to see. They're an exciting event. But your eye's not sensitive to colors in low light. So typically, when you see an aurora at this particular latitude, they're not going to be very bright. You're going to need dark skies to see them. And although I could sense some color, especially the greens where the eyes are most sensitive, this spectacular display of color that we see right here is not really apparent to the eye. So photographing auroras, you actually get a better product than what you actually see. Here's another one. This is one that I took again from my home location. In this one we can see, this was an interesting aurora because this had a lot of reds in it. And typically you get a lot of the reds, from what I understand, when there are a large number of protons hitting the top of the Earth's atmosphere. The different colors usually reflect where the particles are interacting with the atmosphere. So these blues and these greens, typically the greens are more apparent for the interactions lower in the atmosphere when electrons are hitting. Eclipses. If you ever get an opportunity to see a solar eclipse, I actually traveled. I went down to North Carolina to see the last total solar eclipse in North America. And I wasn't expecting too much because I'd seen partial eclipses before. To see a total solar eclipse is really something else. Now, of course, I'm a little more excited about astronomy than most people, but the experience was awe-inspiring. We were in a crowd of people. I forget the town. It was somewhere in the mountains of North Carolina. And you could audibly hear thousands of people gasp as the sun was blocked out. And we'll talk about an eclipse that you'll have an opportunity to see. So an eclipse happens either when the moon passes in front of the sun, blocking the sunlight on the Earth. These are the really, most impressive eclipses. We call these solar eclipses because the sun is being blocked out. Or when the Earth casts a shadow on the moon, and that, of course, is a lunar eclipse. If the orbit of the moon were perfectly lined up with the plane of the orbit of the Earth, we would get an eclipse during every full moon. That would be a lunar eclipse. We'd get an eclipse during every new moon. That would give us solar. However, the orbit of the moon is slightly inclined. So only when it crosses our own orbit, at the same time the moon is exactly full or new, will we get an eclipse. We call these nodes where it actually crosses. So the node has to line up just perfectly when full or new moon takes place. That makes this event actually quite rare. In fact, for the lunar eclipse, that's a more common eclipse to see because we're looking at the Earth, we're looking from the Earth at the moon, and we can see the moon from pretty much half the locations on the Earth, and thus half the Earth is going to be able to see a full lunar eclipse. A total solar eclipse, however, the shadow of the moon comes down to a point on the Earth. So really only a small region, that's why I traveled down to North Carolina, can see the solar eclipse. All right, so once again, during a new moon, we get our solar eclipse where the moon shadow comes to a point on the Earth, so a very small location on the Earth gets to experience this. Or during a full moon, we can get a total lunar eclipse. All right, so here is our solar eclipse. Again, the moon has to be lined up just perfectly during the new phase. It tapers down to a point, and it's not quite a point. We actually get an elliptical area on the Earth. If you're within that path, you get to see the photosphere blacked out, and suddenly the corona of the sun appears. Spectacular to see. And again, just this region experiences the total eclipse. If you watch the eclipse from this location, you would have seen, just the moon taking a little piece out of the sun. Might have been a little bit darker here, but certainly it doesn't become dark like the total eclipse. So during a total solar eclipse, the brightest part of the sun is covered. This is actually called the diamond ring, where just a small part of the photosphere peeks out. This allows us to see the corona, again, it's not a very common event. Here is the eclipse that I viewed. This was in 2017, August 21st, 2017, and I was sitting right here on the western part of North Carolina. It was just, something to see. We're in the mountains. The sky went dark. It actually got colder, so that was really, really impressive. The eclipse that you will have the opportunity to see will be in 2024. So in about 4 years, April 8th, an eclipse will actually pass on the northern part of New York. I gotta warn you, April is not a great place to view an eclipse on the East Coast. We know April showers. The sky is often cloudy during these times, so we'll talk about where you'll have the best chance of seeing this. Here's a list of all the eclipses up to this year, and again, you can see that they're very, very much localized. And the eclipse in 2024 is not shown here. Here's the eclipse that I viewed. It actually started in Oregon, moved across the United States, and I was pretty close to the point of maximum totality when I viewed this. The blues represent total solar eclipses. The reds represent annular eclipses. That's when the moon is further away from the Earth than it normally is. It's on what's called its apogee. And when that happens, it doesn't produce the totality where you can see the corona. Okay, so taking a look at this eclipse right here, this is the eclipse from 2017. You can see the point of totality moving across the United States. This larger shadow right here was actually where you could have seen a partial eclipse. Again, I've seen a few partial solar eclipses, and they were really nothing compared to totality. So again, get an opportunity to see the 2024 eclipse, take that opportunity. Here's a picture that I actually took of the 2017 eclipse, and the weather wasn't perfect. I actually took this picture, and you can see the corona. I didn't have a very sophisticated camera, but the corona is pretty much peeking out through the clouds, and you can see these pink edges right here. That is the chromosphere. So this is really quite a neat. Franklin, North Carolina, that's where I saw it. And here's some pictures that I took of the eclipse. I actually projected this from a telescope on a piece of paper. You can see the creases of the paper that I used. And you can see it getting closer and closer to totality, and then totality. So now, 2024, here's your opportunity to see the eclipse. Again, you don't have to travel very far to be in the path of totality for this particular eclipse. You can go in upstate New York, Ohio, there are a number of different places that you can go. Here's where the problem is. This is a map of the average cloud cover for April 8th. And what we can clearly see, let's say if you go up near Buffalo or you could go near Syracuse, you're in the orange, which, represents a little greater than 50% chance that the sky is going to be cloudy. That's not really great if you're making that trip. Really, because of the weather, your best chance of seeing this, and I hate to say this because it's April, we probably all have work or school. In 2024, if you really want a good chance of seeing this eclipse, Mexico or Texas, if you don't want to go too far. But really, your best chance is right down here, right near the Rio Grande. And there, we look at it climatologically. Your chances are actually pretty good that the skies are going to be clear given the weather down there. But again, another eclipse for North America. Unfortunately, the weather is not so favorable that time of year. Lunar eclipses, these are things that you've probably seen a lunar eclipse before. I've seen many, many lunar eclipses. And this happens when the moon passes into the Earth's shadow. Why are lunar eclipses so much more common than solar eclipses? Well, first of all, the Earth is bigger. It casts a bigger shadow. So therefore, the likelihood that the moon's going to pass in the Earth's shadow is much greater than the Earth falling into the moon's shadow. Okay? Again, more than half the Earth can see a lunar eclipse when it happens. Only a small point on the surface of the Earth can actually see a total solar eclipse when that happens. Bad news, folks. Not many lunar eclipses in our near future. They're always sort of interesting to watch. As the moon passes in the Earth's shadow, light will leak around the sides of the Earth through the atmosphere, and the reddening of the atmosphere actually projects onto the moon, giving this reddish color. Sometimes we call it a blood moon. And again, the light that makes it around is scattered by the atmosphere. And as we talked about early on, it's pretty reddened by the time it gets to the moon. So what is our next total lunar eclipse? Well, not until 2022, May 16th. So we really don't have anything this